In this video, I will provide you visual examples of common sedimentary rocks. I'll describe the rocks by their texture and composition as applicable. While not covered in the lecture text, sedimentary rocks provide incredible context of the geographic environment at the time of deposition and can be used as a proxy or a variable that is not in itself directly relevant, but that serves in place of an unobservable or immeasurable variable for climatic conditions. Now, I do want to note what climate is by definition, and that is an extended record of temperature and precipitation amounts. So as I progress, I will annotate or hover over the rock I am describing with a red laser on the slides where there are more than one example present. So these are key clastic textured sedimentary rocks. There is a conglomerate, a sandstone, and a shale. Conglomerates, as seen here, are predominantly composed of clasts 2 millimeters in diameter or larger, and these clasts are rounded in shape. Conglomerates require higher energy environments like stream beds or glaciers to mobilize and round these larger grains. Smaller clays and muds and sands often fill in the spaces between the larger gravel-sized grains, as well as cements, as observed here in this example. This darker color is composed of smaller clays, muds, sands, and cement that are holding the larger pieces together. Sandstones, as seen here, are predominantly composed of grains 1/16 to 2 millimeters in diameter, and these grains can be angular or rounded in shape. Beaches, dunes, and streams are ideal environments for sandstones to form. Sandstones may also have clays or muds fill in the spaces between the larger sand-sized grains, as well as cements, just as we observe in the conglomerate example. Sandstones are typically various colors, and those various colors can indicate their mineralogical compositions. In this example, this sandstone is composed almost completely of quartz, which is an opaque mineral, yet there are orange hues from iron oxide, also known as rust, which either have stained the quartz grains or are present in the cement. In this example, a shale, the clasts are less than 1/256th of a millimeter in diameter. And at this size, clast shapes are indistinguishable. Shales and siltstones are formed in lower energy environments like lakes or the mouths of streams. Typically, shales are so fine-grained, compaction alone is not enough to lithify the sediments. Additionally, observe the layers in the shale. These layers are also known as beds. Not all shales are black, as they are here in this example. Shales can vary in color from beige to yellow to red to brown to black. Also, often associated with shales are claystones and mudstones. While claystones and mudstones are composed of grains the same size, they do not retain any of the layering that shales and siltstones retain. Next, onto our key chemical texture, aka our crystalline textured sedimentary rocks. The three examples I have here are rock salt, limestone, and chert. Rock salt, seen here in this pink to orange sample, is crystalline, and it's composed entirely of the mineral halite. Not all rock salt is pinkish orange in color. It can vary in color, including cream, white, or shades of brown. Do note that there are individual halite crystals that precipitated out of water that then underwent lithification. Here is one variation of a limestone that has a finer crystalline texture. This limestone is composed of the mineral calcite that likely precipitated out of water in a shallow sea. The calcite fell to the seafloor and then underwent lithification. Calcite typically only forms in warm, shallow marine environments. And again, limestones can vary in color. Recall, limestones are composed of the mineral calcite, and as such, limestones dissolve with dilute acid. And environmentally, this is important for groundwater resources, but also hazardous because it is often associated with sinkholes. The last of our crystalline textured examples here is chert. Chert is a microcrystalline sedimentary rock which can form from silicon dioxide or quartz mineral ions that are precipitating out of water, or biochemically as the hard shells of certain plankton called diatoms, where both of these sediments fall out of suspension and undergo lithification. It is impossible to differentiate whether chert formed from chemical precipitation or biochemical precipitation without the aid of a microscope. Thus, chert is microcrystalline. The individual SiO2 sediments are indistinguishable. I cannot point to individual crystals here in this sample. Additionally, the color of chert is variable. Essentially, all colors are possible. Here on the central coast of California, we see a lot of chert that is reddish brown in color. But chert can even be bluish and purple in color. And as there can be exceptions to rules, our last example is coal. Coal does not particularly fit into either clastic or crystalline textures. And those sedimentary rocks like coal that have an organic composition don't particularly have a texture other than layered. There are various types of coal, including peat, lignite, and this example shown here called bituminous coal. Bituminous coal is very lightweight, it's black, it's shiny, and it retains layers. I believe you can closely examine and see what look like stripes. These stripes are layers within the bituminous coal. We will come back and revisit coal later in the semester when we discuss fossil fuels. That's it for sedimentary rocks.